Welcome back to my YouTube channel Harita Tech Learning. Today we are discussing about AXI Protocol. AXI stands for Advanced Extensible Interface. It is a high-speed AMBA protocol from ARM Holdings used for communication between components in an SoC. The AXI protocol, it is suitable for high bandwidth and low latency designs, provides high frequency operations without using complex bridges, meets the interface requirements of a wide range of components. It is suitable for memory controllers with high initial access latency, provides flexibility in an implementation of interconnect architectures. It is a backward compatible with existing AHB and APB interfaces. Key features of AXI protocols are separate address, control and data phases, support for unaligned data transfers using byte stropes, uses bus-based transactions with only the start address issued, separate read and write data channels that can provide low direct memory access, support for issuing multiple outstanding addresses, support for out of order transaction completion. It will permits easy addition of register stages to provide timing closure. AXI we have 5 channels: write address, write data, write response, read address, read data. In simple definition, AXI is a fast communication protocol that transfers data efficiency protocol between CPU memory, DMA and peripherals. DMA transfer direct memory access. AXI architecture. AXI is a bus-based protocol that has 5 independent channels for communication. Read address, it will sense read address control information. Read data, returns data from slave to master. Write address, sends write address control information. Write data, it will sends data from master to slave. Write response, it will confirms write completion. How AXI works: master sends address on read address channel, slave sends requested data on read data channel. Write transaction, master sends address on write address channel, master sends data on write data channel, slave sends completion response on write response channel. Important features: address can be sent before data, supports multiple pending transactions, transaction can complete in different order, it will improve speed and through output. Channel definition: each channel works independently with its own signal. Every channel uses a valid to ready handshake mechanism. This handshake ensures safe and synchronized data transfer. Valid and ready signals. Valid signal for source to master indicates that address, data or control information is valid. It means data is ready to send. Ready signal from destination to slave. It indicates that the receiver is ready to accept data. It means I can receive data now. Data transfer happens only when valid and ready equal to 1. Last channel: when both read data channel and write data channel includes a last signal. Last signal indicates final data transfer in a bus transaction, helps identify transaction completion. Read and write address channels. Separate address channels for read and write. Read address channel and write address channel. These channels carry address information, control signals like bus type, size, etc. Read data channel transfers data from slave to master. Transfers data from slave to master. It contains read data, read response, status of transaction. Data bus width can be 8 or 16, 32, 64, 128, 256, 512, 1024 bits. Read response shows success or error of read operation. Write data channel transfers data from master to slave. It contains write data, byte LAN strobe signals. Byte can LAN strobe indicates which byte of data are valid. Write data is buffered. It means master does not wait for slave acknowledgement before next write. Write response channel used by slave to respond to write transaction confirms completion of write operation. Every write transaction must get a response. Interface and interconnect. A typical system has multiple masters and multiple slave devices connected through an interconnect. The interconnect acts like a communication bridge between all devices. In AXI protocol, it provides a single interface definition for the interfaces between a master and the interconnect, between a slave and the interconnect, between a master and slave. This interface definition supports a variety of different interconnect implementation. Most digital systems use one of these three interconnect topologies. Three are shared address and data buses, shared address bus plus multiple data buses, multiplier interconnect. Third one is in shared address and data buses, all masters and slaves share same address bus and same data bus. Simple architecture but performance limited due to bus contention. In shared address bus plus multiple data buses, address bus is shared among all devices. Multiple data buses are shared for data transfer. Enables parallel data transfers. Better performance compared to fully shared buses. In multiplayer interconnect, the multiplayer independent address and data paths allows multiple transactions at the same time. Highest performance architecture used in high performance SoC designs. Register slices. Each AXI channel transfers data in only one direction. Channels operate independently. What is register slice? A register slice is a pipeline stage inserted in a channel. It helps to improve timing by breaking long paths. AXI components and topology. Component: any device or block that participate in AXI communication. Master component: it initializes the transactions, starts read or write operation. Example: CPU DMA. Slave component: response on master request. Types: memory slave like RAM, ROM, peripheral slaves like UART, SPI, GPIO, etc. Interconnect components are connects masters and slaves, routes address data and control signals. Upstream and downstream, used to describe position in AXI system topology. Upstream, direction towards the master side. Downstream means direction towards the slave. AXI transaction and memory types. When a master starts an operation, it creates a full AXI transaction. AXI transaction, complete operation between master and slaves. It includes address, data, response phases. AXI bust. AXI bust is part of transaction. It carries the actual data payload. A burst can contain multiple data transfers. AXI bits. Each individual data transfers inside a burst is called beta. One burst it is equal to multiple bits. Caches and cache operation. AXI does not define cache terminology. Caches concepts are taken from general computer architecture. However, cache and cache line are used in AXI context with standard meaning. Signal description. We have signals like global signals, write address signals, write response signals, write data signals, read address signals, read data signals. Now we will start with global signals. Global signals are clock and reset. A clock stands for, it is for global clock signal for AXI system timing. A reset and active low global reset signal for initialize the system. Write address signals or AWID. It is write address ID signal used to tag and identify write transaction. AW address. It is write address indicating the start address of the burst. AW length. Burst length defining number of data transfers in a burst. Write address size. Burst size indicating bytes transferred in each bit. AW burst. Burst type defining how addresses increment in a burst. Write address lock. Lock signal indicating atomic lock transaction type. Write address cache. Memory type signal indicating defining caching and buffering behavior. Write address protection. Protection signal indicating privilege, security and access type. AW write address QoS quality of service identifier for transaction priority. Write address region identifier enabling the multiple logical interfaces on one slave. Write address user. Write address user. User defined optional signal for custom information. Write address valid indicates valid write address and control signals from master. Write address ready indicates slave is ready to accept write address and control signals. Write data channel. Write ID tag identify the write data transfer. Write data bus carrying the actual data from master to slave. Write strobe indicating valid byte lands in the data bus. Write lost, it indicates the lost data or transfer in a burst. Write user, optional user signal for custom information. It is used in AXI 4 only. Write data valid indicates valid write data and strobes are valid available from master. Write ready indicates slave is ready to accept write data. Write response channels. Write response ID tag identifying the corresponding write transaction. B response. Write response status indicating success or error of the write operation. B user. Optional user defined signal is write response channel. It is used in AXI 4 only. B valid indicates slave is providing a valid write response. B ready indicates master is ready to accept write response. Read address channel. Read address in ID tag identify the read transaction group. Read address being the start address of the read burst. Read address length. Burst length specifying number of transfers in read burst. Read address size. Burst size defining bytes for transfer in each bit. Read address burst. Burst type defining the how addresses change in burst transfers. Read address lock. log signals indicating atomic read transaction type, read address cache, memory type defining caching behavior of read access, read address protection signal indicating privilege, security and access type, read address quality of service identifier for read transaction priority, read address region identifier supporting multiple logical interfaces for slave, read address user optional, it is used in AXI 4 only. Read address valid indicates valid read address and control information from master. AR are ready. Read address ready indicates slave is ready to accept read address and control signals. Read data channel. Read ID tag identifying the read data transaction. Read data bus carrying data from slave to master. Read response indicating status of the read transaction. Read lost indicates lost data transfer in a read burst. R user optional user identifier, it is read data channel, it is using in AXI 4 only. R valid indicates slave is providing valid read data. PR ready indicates master is ready to accept read data and response. Low power interface. C system as request. System clock controller signal requesting the peripheral to exit low power state. P system acknowledgement peripheral acknowledgement signal for exit from low power state request. Channel active indicates peripheral is active and requires the clock signal. We will continue in next video.